Hello again, guys. Welcome to the second video lesson for this week. This lesson is going to cover homeostasis in plants. So in the previous video, we talked about homeostasis within the human body, how our body keeps that balance. But now we're going to talk about plants because plants have to keep homeostasis also. It's vital to their life. Let's start off with this. When we talk about homeostasis in plants, the biggest concern is water levels. Obviously, there are other things that are concerned, but water levels are a really key one. So we got to have good homeostasis or a good balance for the survival of the plant. Now, how do we do that? Well, first of all, you guys get a leaf, maybe in your backyard, a tree or something, in your backyard or something, and you probably never really noticed this. I know I didn't until I learned this. But if you look at a leaf, it's actually both the sides of the leaf are actually look different. Like one side is a little smooth, almost like a waxy cuticle. And on the other side, it doesn't have that waxy film. It's almost like kind of rough. If you look really closely, you can see little bumps. Why is that? Well, the structure, the very structure of the leaves has to do with homeostasis. So grab a leaf, guys. I probably should have told you that in the beginning. Grab a leaf. If you want to pause the video right now and run outside and grab a leaf, or if you have plants in the house, take a look at one of the leaves of the plants. You should see that one side might be waxy, smooth. The green is darker. When you look to the other side, it's a lighter green. Might be a little bumpy if you look real closely, like little bumps on it. So we're going to talk about why it's that way. Well, first of all, one of the ways that plants maintain homeostasis or control their water levels is they have what they call a waxy cuticle on the leaves, and that's what that top layer is of the leaf. When you look at the leaf, and I know you can't see it in my video because it's green, like my green screen, so you're seeing the letters. But when you look at your leaf, you'll notice that the part that faces the sun is darker, okay? And it's smooth, like I said. That's that waxy film. It's like a wax that's on it, okay? And if you think about wax, think about waxing a car. Now, if you guys have ever washed a car and you put wax on it, you probably know that wax repels water. In fact, after you wax a car, when you throw water on the car, the water beads. The water turns like a little ball and it rolls right off. Okay, that's because wax repels. It's hydrophobic. So when the water hits it, it kind of repels the water molecules. Hence, the water molecules will bubble up and will just roll off. So it's likewise with the waxy film on our leaf. So the top part, it's waxy. So when water hits the top of the leaf, it kind of just rolls right off. Okay. But on the other hand, the water that's inside of the leaf can't get out. At least not here. Not at the top part, it can't. And this is the part that the sun is facing. So let's think about that. What does sun normally do to water? Remember in the last video, we were talking about sweating and how sweating cools us down. Remember the process of it? Remember how that worked? Remember, we release sweat. The sweat goes onto our skin. The sun, the heat, the air outside is going to cause the water on our skin to evaporate. And when it evaporates, it takes away the heat from our body. Well, think about a leaf. The sun is hitting here. If the water in the leaf, if we didn't have the waxy cover, the water that's in the leaf would just evaporate right out of here. And think about how fast that would be because the sun is so hot, right? Think about how much water the plant would lose off the top of the leaf if it didn't have the waxy film. So that waxy cuticle kind of like locks in the water. It prevents the water from evaporating this way. Even though the sun is shining here, it's not going to allow the water to leave off the top of the leaf because it evaporates too fast. It won't be balanced properly, so we protect the top part, okay? So we're protecting the top part from water leaving because we want to control the amount of water leaving, okay? So also, as you guys can see here, our leaves, because we have this waxy cuticle, that's one of the way that we store water. And we can control what's leaving the leaf with something called a stomata. Okay, so instead of just having water evaporate randomly, like it would on our skin, the plant controls it by having, again, that waxy top, holding in, storing the water, so we don't let it just evaporate. But we control it by opening and closing something called the stomata. What's that? Well, take the leaf, now flip it over. Notice again, the bottom part doesn't have that waxy, that thick waxy look. It has a different look to it. It's not as dark, okay? It's not as dark because photosynthesis really occurs on this side of the plant. That's why this part is facing the sun, because the photosynthesis happens on this end. On this end, it looks different. If you look real carefully, you can see little like bumps, like little ridges, if you want to call it that. Now, if we had a microscope, a really powerful one, this is what you would see. Looks kind of weird, doesn't it? It reminds me of like lips, like kissy lips, like this. It reminds me of kissy lips. So this here is called the stoma, and that's what's on the bottom. Those little ridges that you see, the little itty bitty ridges and stuff, they're all part of the stoma. They're little tiny pores, little tiny openings at the bottom of the leaf, okay? Little pores. Why are they there? That is where the plant can release, can take in carbon dioxide and diffuse out oxygen. Now, remember we talked about photosynthesis, right? You know that. Plants taking carbon dioxide, and then it releases oxygen as a waste product. Well, have you ever wondered, where does this happen? In the leaf. It all happens at the bottom of the leaf. So remember, the leaf is like this. The sun is shining this way, photosynthesis. But underneath the leaf, the part that's not as green, that's where this is happening. You have the little stoma. They open and close like little kissy face, like this. That's reminds of kissy faces, right? Okay. It can take in carbon dioxide, release oxygen, and all that happens underneath. The stoma has something called guard cells. Guard cells looks like the little lips, that little fat part there, the kissy lips, okay? So that part there is what opens and closes. The stoma is the actual like hole, okay? The actual opening is a stomata, or sometimes they call it stoma. So the actual hole, that hole you see in between, is the stomata or the stoma. The fat-looking lips on the outside are the guard cells. They guard the opening. They're the ones that decide when it should open and when it should close. So in the stomata, not only is carbon dioxide and oxygen allowed to enter and release, but also water. So this is where water can be released gradually when the time is right. Now we got to think back because we did this. Remember we did the cycles and we did the oxygen cycle, and we talked about how, one of the ways that oxygen is cycled is through carbon dioxide and oxygen, of course, going in and out of the plants. Remember we also talked about with the water cycle, we did transpiration. Remember that? Remember we talked about how water leaves a plant and we called it transpiration. Whereas like if water's in a pond and it evaporates, that's evaporation. But when water leaves a plant, we call it transpiration. Well, this is where the transpiration takes place, underneath the plant, underneath the leaf. So when the little guard cells open up, when the little kissy mouth opens up, the stomatas exposed, it will release water, release carbon dioxide, and will take in, let me say that again. It will release water, release oxygen, and it will take in carbon dioxide. This guard cells regulates the rate at which it's going to open and close, how long it stays open, when it shuts, and things like that. So, for instance, I think it's this one here. So, the stoma when it's open, again, when it's open, can release water. When it's closed, it doesn't. So this is how the this is how the plant can control how much water it loses and when it loses it. So for instance, during a hot day, that stoma might stay closed because it's so hot. It's probably not going to want to open up and release too much water. Whereas maybe later on in the evening when it's a little cooler, it might open up and release some water. So it depends on the time of day. The plant knows when to open up and allow the water out. Like it says here, it naturally is going to allow this thing to happen through evaporation that we call transpiration. So it all depends. And when the plant feels that too much water is leaving, the stomata can close. So isn't that cool? That this is how the plant does it. And again, all it happens at the under part or the bottom part of the leaf. Pretty cool, huh? Yeah. Now, why does a plant have to do that? Why is this so vital? Well, because again, that's how plants are going to regulate its water loss and gas exchange. This is how photosynthesis takes place. The guard cells are the ones that control the opening of the stomata. It controls when it opens, how long it stays open, when it closes. And again, that's where the water's going to leave, oxygen's going to leave, carbon dioxide comes in. At night, when photosynthesis slows down, water can exit the guard cell. So during the day, when I got some photosynthesis going on, the stomata can control when to let in the needed carbon dioxide and when to release that oxygen. At night, it can control when the water leaves. So all of that's happening one more time at the under part of the leaf. All because of the guard cells or the lips opening and closing the stoma or the stomata, allowing things in and out of the cell, in and out of the leaf. And just through that tiny little thing, an entire enormous plant like the redwoods, where you guys live, can live. All of that can happen simply because of that. Now, just the last thought here, just to kind of tie it all in together, the two forms of homeostasis. So we talked about homeostasis in humans, which was a very complicated, that was a very long lesson, I know, because our bodies are so complex. When we're talking about homeostasis in plants, I kept it really simple. We just focused in on the water aspect. But really, guys, why is this so important? Just to kind of tie it all in. Guys, if our bodies does not maintain homeostasis, if our body cannot respond to changes, that results in disease or death. If you cannot, like if, for instance, if a person can't sweat, and that is a disorder that can happen, that's a problem. That person is always in jeopardy of overheating, and overheating can lead to death. If something's wrong with our immune system, if we can't respond to an invasion, if we can't warm ourselves up, if we cannot respond, that's not a good thing. Remember, any type of imbalance in our bodies, something's wrong. It could be disease. Something's just not right, and your body will tell you that. What would happen to a plant if they couldn't slow down the water loss? Let's say that the guard cells weren't working properly and the plant is losing too much water. Well, guess what? What happens to a plant if it runs out of water, if it's not enough water? You guys have all seen it. The plant wilts, collapses, and dies. It literally shrivels up. Because if we, and I'll be the first one to say, I do not have a green thumb. I have killed plenty of plants in my life. I didn't kill cactus. That's terrible, but it's true. The point is, if you don't give a plant water, when the stoma opens, because of the guard cells, because it does have to open, right? It has to open for photosynthesis to occur. So whenever it opens, some water is going to get released. If you're not giving a plant water to replenish the water that's leaving the leaf, eventually the plant dies. Homeostasis. When we don't keep that water balance, we don't keep that important balance, things die. things get sick and they die. And so that, I mean, that's really what it all boils down to, guys. So that's it. That's homeostasis. Okay, so we've gone over homeostasis in human beings. We've gone over homeostasis in plants. We're done. All right, so what's next on the list? We'll take a look at the agenda. Any videos that I have there for you to look at, please look at them. It's to help build on what we've learned. It's to give you a different visual, and it's to help present the information in a different way. Please feel free to re-watch the videos if you need to review any of this information prior to taking your quiz. And that's it, guys. I hope you enjoyed this topic. It is so interesting. And of course, we only scratched the surface of homeostasis just to give you a little bit of a taste, kind of like appetizer here. There's so much more to learn. And so, like I said, we're going to end it here. Enjoy the rest of your day, and I will see you guys online. Take care. Bye-bye.